Hi, friends. Here's our last lesson for the week. And then the Easter Bunny comes. I can't wait. So, we are going to do some volume of pyramids and spheres in this lesson. It's going to be great. So, look at the pyramid. Notice that it's not full shape. So, this is one of those fun ones again. That's going to be a third, 1/3 big B times H. Now, unlike the cylinder where it was pi r squared for big B, the base of the pyramid can change. The base is a square, or it could be a rectangle, like the third example or second example there, or it could be a triangle. That's even crazier. So let's look at some fun examples here. I'm going to do a few of these. Some are easier than others, so I'll leave the easier ones for on the actual PDF version of the notes that are filled in for you. But let's look at this fun example here. So we have this like triangular pyramid, and the problem is the base has this as 6, and this we don't know. See, the base and the height are different there. So I can't use the 10 in the volume of the base because that's actually the hypotenuse of that right triangle. So to get started, I need to use a squared plus b squared equals c squared on the base out exactly what the height of that triangular base is. So 6 squared plus x squared equals 10 squared. And if you're a genius, you know that this is a 6, 8, 10, or a 3, 4, 5 right triangle. That's a triple multiplied by 2. You could also do the math out, but since you guys are in honors, you know that's an 8. Okay, so now I have volume equals 1/3. The base is 1/2 base times height, because that's the area of a triangle, times another height, which is the height of the whole shape. The height of the whole shape is actually 15 for its pyramid. I've got 1/3, and I just found 1/2 of the 6 times the 8. Look at all these numbers. So much fun. So if you take 1/3 of 1/2 times 6 times 8, well, that's 48, and 1/2 of 48 is 24. So now I have 1/3 of 24 times 15. 1/3 of 24 is 8. 8 times 15 gives me a volume of 120 feet cubed for that fun pyramid. I had to use a little Pythagorean theorem there, but that was fun. Okay, so now let's go down in here and try another one of these. Let's see. One that's really tricky is right here. Number 3. It says a right square pyramid has a height of 15 centimeters and a slant height of 25. Now, a slant height, if you look up in this first picture here, is the height that's on the actual face. We need the altitude or the real height of the shape. So we're going to have to do some work to get that. Okay, let me try to draw a picture. Oh boy, that's not looking too good. But anyway, there it is. And it's a right square pyramid, has a height of 15. So the actual height is 15 on the inside, and it's so that means that height on the face there is 25. I got to use some Pythagorean theorem again to figure out what the actual like distance is from the height, which is in the center, on out. So I know that slant height's 25. That's going to be my C. And I know one of the heights is 15. The actual height of the whole shape is 15. So I have 15 squared plus B squared equals 25 squared. And when I solve that out, I end up getting my B is 20. Now, what that 20 represents is half the distance of the base's side. So really the whole length on there is 40. And since they said it's a square, that means this is 40. So if I'm using my 1/3 big B times H, I've got 1/3 of times the height of the whole shape. Now the height of the whole shape is not The 25, that's the slant height. I need the height of 15, so I'm going to times it by 15. If I multiply, oh, did I write 1/2? That should be a third. So if I multiply them all together, I end up getting 8,000 for my answer, centimeters cubed. That was fun. We should try another hard one too, because these are tricky. Can't even read. A regular pyramid has a height of 12 centimeters and a square base. Oh, a height of 12 and a square base. So that means my height on the inside is 12, square base. If the volume is 256 cubed centimeters, how many centimeters in the length of one of its bases? Shoot, I'm going to make those X. Okay, I'm going to have to work backwards. Volume equals a third of big B times H. Oh, my Chromie is frozen. Did you see that? Okay, so now I have 256 equals a third of X times X. That's the area of that base times 12. Okay, 256. Do I know a third of 12? Sure, it's 4. And X times X is X squared. Look where we're going. Divide both sides by 4 squared equals 64. And that's so fun. X is 8. And guess what? Each side or length of the square base is 8 centimeters. That was fun. Okay, let's move on to our next shape and our last shape for the week, which is the volume of the sphere. Now, spheres can also be broken into two, split by half through a great circle they call the diameter, and that would give you a hemisphere if you split the sphere in half. The volume formula for a sphere is crazy. It's 4/3 pi r cubed. People are going to mess this up. It's not r squared, it's r cubed. Volume is cubed. This time our radius is going to be cubed on the sphere. Okay, let me give you a basic example so we know how to work with this. It says find the volume of the sphere with a diameter of 12. So if the diameter is 12, the radius is really only 6, correct? I'm going to do 4 pi times 6 cubed. Now, if you don't know how to cube something, it's 6 times 6 times 6, or you can hit the math button on your calculator, and there is a cubed option down there. I just punch all those numbers in, or if you want, you can actually cube out that number. 6 cubed is 216. I just type them all in like that. I put them in parentheses in my calculator so it knows it's multiplying them all. And I end up getting 904.77, which is like really 904.8 to the nearest 10th. Very tricky problems. All right, let's look down on the sheet here and maybe try something of like number 4 together. This will be our last example we do, and then I'll have the others all completely filled out for you. It says there are 42 metal spheres, 42 people, with a radii of 4 meters are melted, and the melted solution is poured into a box with base dimensions of 5 meters by 2. We want to find the height of the cube filled with the solution to the nearest 10th. Holy cow. There's a lot going on there, people. So let's first find the volume of one of these spheres. Okay, so volume is 4/3 pi r cubed. It's cubed, not squared. So 4/3 pi, our radius is 4 cubed. If I multiply all those together in my calculator, I end up getting 268.082, blah, blah, blah. Now I have to take that, because that's just one of them, and times it by 42. Okay, so now I have 11,259.46 and a bunch of other decimals. Now, that is the volume of all those spheres melted. So it's asking me to find the height of this base, okay? So it has dimensions of 5 by 2 for its base there. So I'm going to do volume equals length times width times height because I've got basically a cube going. I've got 5. Oh, my Chromie's frozen again. Look at that nice 5 I just drew. Let me see if I can erase that. I've got 5 times 2, and the height is what I'm looking for. And it equals the volume of all those spheres, that 11,259.46. Well, that's really 10H equals that. And so I'm going to actually just move the decimal place over a little bit by 1. Oh, Chromie is frozen again. Having an issue. So H is equal to 1125.9 meters. And that was super fun. Okay, so there's a lot of reading involved in these questions. Make sure you read them carefully and email me if you've got any questions on them. And also look at the answer key filled out for the notes. Have fun, and I hope you guys have a weekend and get to see the Easter Bunny.